We're now going to continue our discussion of sets by looking specifically at the idea of finding subsets. So we're going to start with this example that says find all subsets of the set blue and red. So the first thing that I want to point out to you is that it is much easier for you to list out subsets if you know how many you're supposed to list out. So there's a rule that says that the number of subsets can always be found by taking 2 and raising it to the n power. And the n is going to be the number of elements in your original set. So what that means for this example is if I look at my set A has 2 things in it. It has blue and it has red. So the n value is going to be 2. So I'm going to do 2 to the second, which I know is really just 2 times 2, and that equals 4. So I expect when I write out the subsets for this particular set that I will have 4 of them. Okay, so let's see if we can list them out. Now, you want to realize that every time you work a problem and you're trying to find subsets, that you are always going to have the empty set as one of your subsets. And you will also always have your original set. So the set that looks just like the problem does, blue and red. So that's 2 of the 4 that I'm expecting. Now, I'll also have subsets that have individual elements in them. So I'm going to have a subset that just has blue, and I'm going to have a subset that just has red. So now I have my 4 subsets for set A. Let's try another one. So now our set has the elements 2, 5, and 8, and we want to list out the subsets. So again, as we begin, let's figure out how many subsets we expect to have. This set has 3 elements. It has 2, it has 5, and it has 8. So I'm going to do 2 to the third. That's going to be 2 times 2 times 2, which is going to give me 8. So as I work this problem, I'm expecting to have 8 subsets by the time that I'm done. So again, we know that we're always going to have the empty set. That's 1. We'll always have the original set. That's 2. We will also always have the sets that have the individual elements in them. So that means we have a subset with 2. We have a subset with 5. We have a subset with 8. We also will have subsets that have 2 elements. So let's choose 2. So we could have 2 and 5. Now understand that 2 and 5 is exactly the same set as 5 and 2, so you don't want to list it twice. We could also have 2 and 8, same as 8 and 2. Or we could have 5 and 8, or 8 and 5. So we now have our 8 subsets of that original set. Okay, one other example. This time the original set has 4 elements. So as I start, I want to say I'm going to expect to have 2 to the 4th for the number of subsets. So 2 to the 4th, if you plug it in your calculator or do the multiplication, you're going to get 16. So this one is getting kind of long in that we have to list out 16 different subsets. So let's go ahead and begin with the ones that are easy. We know that we have the empty set. We know that we have the original set. We know that we have the sets that contain just one element. So -4 as a subset, -2 as a subset, 0 as a subset, and +2 as a subset. We also know that we'll have the sets that contain 2 elements. So that would be the set with -4 and -2. Would be the set with -4 and 0. -4 and +2. -2 and 0. -2 and +2. And 0 and 2. So now we have 12 of the sets, right? We need 4 more. So the remaining 4 are subsets that have 3 elements in them. And sometimes these are a little bit more difficult to come up with. So I know, let's see, -4, -2, and 0 would be one of them. We could do -4, -2, and 2. That would be another one. We could do -2, 0, and 2. That would be another one. All right, and we could do, let's see if we can come up with one more. We could do -4, 0, and 2. So now we have our 16 subsets of the original set E.